Hello, greetings to Dr. Suhari and all the audience. Today we are going to look at the PLW112. In this PLW, we are going to look at the Haber-Bosch process where nitrogen will meet with the hydrogen to produce ammonia. The design production, which is the ammonia, for this process is about 35 tons per day of ammonia, and the conversion of nitrogen in the reactor is assumed to be about 17%. And since the information of hydrogen is not stated in the question, we are going to assume the conversion of hydrogen in the reactor is also 17%, meaning that the conversion of nitrogen and hydrogen in the reactor will be 17% respectively. And in this equation, we can see that 1 mole of nitrogen will react with 3 mole of hydrogen to produce 2 mole of ammonia. So later on, we are going to do the stoichiometry and mass balance by using this chemical equation. And then from this question also, they stated that all the unreacted hydrogen and nitrogen are separated from ammonia product and recirculate back to the reactor. Means that after the reaction, there will be a separator to separate all the ammonia, hydrogen, and nitrogen, where all 100% of the unreacted hydrogen and nitrogen will be separated from the ammonia production and recycled back to the reactor. So this is the schematic, the diagram, and we have 4 streams in total. Stream 1 is the inlet, and the stream 2 is the outlet from the reactor, and then going to the separator. And separator, we have stream 3 and 4, where stream 3 is the stream for the ammonia production, and stream 4 is the recycle stream. So now we are going to look at the MATLAB. Hello, so now this is my MATLAB file, and you can see I have stated all the description, the process description here. And I have started my program with clear all, CLC, and close all. So these are all the process description. And then I will continue by assigning the variables where I have putting the molecular weight for ammonia, nitrogen, and hydrogen for the user to ease the user calculation later. And then for the input section, since I have assigned the variables to be input by our user, where the user can input the desired mass of ammonia in the unit ton and the conversion rate of nitrogen and hydrogen too. So after that, for the calculation section, these are all the formula, the conversion, the formula for us to get the number of mole or the mass of the components in each stream. And then after that, I have this is all the formula for the composition of nitrogen in each stream, where you can see I have stated here N2, N4, and 1. N is stand for mole, number of mole, while M is stand for mass in ton. And then this is the composition of hydrogen in each stream, composition of ammonia in each stream. Same thing where the N is the number of mole and M is the mass of the substance in ton. And then after that, I have calculated the total mass, as we need to check back the mass balance. The mass inlet is equal to the mass outlet. So finally, I have calculated the consumption of hydrogen for 10 days and the amount of recycled nitrogen for 10 days. And lastly, I have exported all the data into the Excel sheet. So now I will run the program. So in this program, the user are required to enter the design production of ammonia, and since the question stated that the design production of ammonia is 35 ton per day, so we will use 35 ton per day too. And the conversion rate of nitrogen as stated in the question is 17%, and we assume the conversion of hydrogen gas in the reactor is 17% also. Hence, here are the results, and all in table form. This is the result for the composition of each stream. And you can see for nitrogen in stream 1 there is 28.793 of ton per day. So this table will be in ton per day, all the unit will be in ton per day, and we can see that stream 1 there is 35 ton per day in total, and stream 3 there is also 35 ton per day in total, which means that since stream 1 is the inlet for the whole process and stream 3 is the outlet for the whole process, so we can say that the mass balance is achieved where our calculation is correct, because the mass inlet is equal to the mass outlet. And then after that, this is the table for the 10 days consumption of hydrogen in mass in unit ton, and this is the number of mole, same thing, but I converted all the information into kilomole. And then this is the mass of nitrogen recycled, and that's all. So I hope you can understand my explanation for today, and thank you for watching. See you next time. Thank you.